The next two ways to solve a system of equations are algebraic in nature, so we're not going to take a look at the graphs. We're just going to try to figure out how we can find the x and y values that will work for both. So there's two main algebraic ways to do this, and the first way is it's called the substitution method. I'll write down the steps to doing the substitution method, and simultaneously we'll solve this system of equations, which is the same system we solved before graphically, so we already know the answer. If you remember from the last video, the answer was, put it up over here, the answer was 1, 3. So we, in the back of our heads, know the answer is 1, 3 from our graphical approach, so substitution should give us the same answers. All right. So in order to do the substitution method, one route, or the first thing we would want to do, is we would want to take either of the equations, it doesn't matter which one, and solve for one of the variables. Again, it doesn't matter which one you solve for, either you solve for y or you solve for x. Sometimes one is easier to solve for than another. So solve for either variable either equation. Doesn't matter which equation you choose, doesn't matter which variable you choose. As a personal preference, or just from experience, right, you would probably find out that it's easiest to pick an equation that has a variable that doesn't have a coefficient other than 1. So if I just have a y or if I just have an x, I'm going to choose to solve for that variable. It's going to be the quickest route to go. So I can pick this top equation and solve for the y, that would be a nice way to do it. Or I can pick the bottom equation and solve for the y, that would be two nice ways to go. So I'm going to stick with the top one for now. So we'll do that. So I'm going to take this equation. So here's step 1. 2x plus y equals 5. And this process should be familiar because we do it all the time when we're changing this equation into y equals mx plus b. We certainly know how to solve for y. We just did it in the last video. Add a negative 2x to both sides, cancel, y equals, these don't group together, negative 2x plus 5. Right. Step 2. Now we know in this equation, since we solve for y, we know what y is equal to. It's equal to a new expression. So what we're going to do is we're going to take this expression that we know is equal to y. So negative 2x plus 5, we're going to take it. And we're going to go to the other equation, the equation we didn't solve for, and then to replace y, we're going to replace y with negative 2x plus 5. So we're going to take this plop it in there for y into the other equation. So that's what I'll write down here. So substitute in the other equation for the variable just solve for. Not the greatest sentence, but I think you get the point. We solve for y, so in the other equation, I'm going to replace y with what we now know y to be. So for step 2, instead of negative 4x plus y equals negative 1, we'll have negative 4x. Instead of this y, I'm going to replace it with negative 2x plus 5 equals negative 1. So we got rid of this y by substitution. Now we have an equation that only has x's and constants in it, so this looks like an equation that we could readily solve for x. Okay, so we solve the equation for the remaining variable. So since we substituted for y, we only have x's left in this equation, so this looks like an equation we can handle. We have, all right, two like terms over here that can group together. That'd be negative 6x plus 5 equals negative 1. We can add a negative 5 to both sides. We have negative 6x equals negative 6. Divide by negative 6. And x equals 1. So that's half the game. Okay, because remember our solution has to be an x value and a y value that works, but we did match up the x values here. So we're halfway home. I guess this would be part 2 and part 3. All right, but we did all the hard work. All right, all the hard work's done here, solving for a variable, substituting it in, and finding out what the remaining, one of the remaining variables is. So we have x equals 1. All right, in this method, once we have one part of the solution, this is going to be the same for this situation, substitution, in the next video. All right, once we have one answer, we can always take this answer, go back to either one of the equations we started with, it doesn't matter which one, right, and we can take our x value of 1 and substitute it in, right, for x in either one of the equations, it doesn't matter. So step 4 would be to take your solution and substitute into either original equation. And once we substitute it into either original equation, we can finally solve for the final variable. All right, so these last two steps, all right, we'll show right over here. All right, I'm going to use this equation. The top one, 2x plus y equals 5. It doesn't matter which one I choose. All right, but we're going to take this x value, we're going to go and substitute it in for x. So we have 2 times 1 plus y is equal to 5. So that'd be step 4. This would be step 5. Right, so we have 2 plus y equals 5. Subtract 2 from both sides. And we can find out that y is equal to 3. So we had an x value of 1, took it, substituted it into our top equation, and it wouldn't matter which one we did, but we substituted it in, and then we have just y's left over, solve for y, and we get our final answer of 1, 3. All right, this method is very helpful, and you can kind of see when it's going to be helpful. If you're looking at the original equations and you see just a single variable involved. If that's the case, substitution might be your quickest, most efficient route to getting the answer. Right, if I've got coefficients on all of these, right, that are not 1, the substitution method probably isn't the best route to go. But as soon as I see an individual variable like this, I might think substitution will be the best. Right. So in our next video, we'll take a look at the other algebraic approach that works in a more broad range of situations.